Able to see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Some problem getting stuck. Yeah. Okay, this is the one force acting like this. Fine. So this will be another force, F2, F3 this is. Screen got stuck. Huh? Another force called F3 here. Now look at this. Which force will provide the centripetal force? I don't know what is the problem. Just be there. Some update has come because of that. It's creating problem. Okay, are you able to see clearly all things? Screen, everything fine?
Yes, sir.
Some background driver problem was there. Now, we will provide the centripetal force F1, F2, F3, and also you do one thing. There's a one very best idea I'm giving for the students. Really, you should utilize this. This one. We will provide centripetal force F1, F3, F4, F2, and it's having a tangential velocity. Let me write this is V. Now, what should be the and R? So, what I should write mv square R equal to? So, it should be equal to F1 plus F4 cos alpha minus F2 cos theta should be equal to mv square R. Getting the idea now? What is F3? F3 will become tangential force. This everything will become, you should call it as centripetal force. And what about F3? F3 plus F2 sine theta plus F4 sine alpha should be equal to MAT. I'm not showing that tangential, it should be understood. So this everything will become tangential force. Okay, got the idea now? So this is a basic idea. So we will provide a component of like a A resultant of all forces acting towards center will provide required centripetal force. This is the basic definition. So centripetal force means need not be one force. It can be any number and it can be a component. So the resultant of all forces acting towards center will provide required centripetal force, and that should be equal to mv square r. Got the idea, no? So this is circular path. All your numerical just revolves around this finish word. So you should really thank teacher. Okay, sir, you gave a very good idea. Okay, now I'll start problem. That's all your numerical just revolve around this basic idea. Okay, let me take the next condition. That was a conical pendulum, no? So here we'll take one more. This is a rod. This is a length L. So there are two rods are there, like, you know. This is a rod, and this one is another rod here. So now I'm going to whirl these rods. And this yellow color is also a rod. Huh? I'll write it. So this is a horizontal rod. This is a vertical rod. Rod 1, rod 2. I'm going to whirl it. And the one end of string is connected to rod, and I'm going to move in a circular path. So where this will make an angle theta. Now, so this is, I think you might have played such objects in when you were a kid. Instead of holding the string here, so you can connect the string, one end string to the rod, and the rod connected to, and this you rotate it. Then what is the path of this? How do it rotate? Will it rotate about axis? Will it rotate about the rod one, or will it rotate about point A? This is related to common sense, nothing to do with physics here. So where do it will rotate? It will rotate about which one? About the vertical rod one. This will be the path. I'll extend this rod further. So now how the path of the particle, the path of the particle will be. In this one, so the rod what pen will rotate, the bob will rotate about this particular point. So what is the radius? This will be the radius. So now, so let it have a velocity v. So let it have a velocity v like this. Now I want the overall expression for the time period of revolution. So this will be the tension T. O will provide the weight will act like this, mg. Component of tension T cos theta minus mg equal to 0. T sin theta is equal to m v square r. What is r in the diagram? Radius, no? So what should be the r? R should be equal to L plus L sin theta. With this one, L plus L sin theta. How that L? This is L. So if you draw a triangle, it will be like this, no? What is this distance will be? L sin theta. What is the radius of this circular path of the bob? L plus L sin theta. So this you are going to substitute here. Then we wanted the time period, no? So this you can write it as T sin theta equal to m omega square. Various types of systems you are going to come across. From here, mg cos theta. So what is the tension? You can write it as mg by cos theta. So what is omega is equal to G tan theta by L plus L sine theta. This is the angular frequency. If you want time period, what you should do? T naught equal to 2 pi by omega. Different types of rotating systems I'm just bringing. Now, all powered centripetal force, again, component of tension only. Okay, fine. So I do suggest all you can try this in home once. Okay, you feel, oh sir, what I'm studying is only this much. Yes. So now from today onwards, what you should do? You should make out observation of various rotating systems. Don't look here and there. Don't imagine all that movies, cricket, all stupid that one. Come out of that imaginary world, because I've seen most of the southern state, no, they are more creative in what the movies. Even the youth also will give much priority for what, like the songs, that movies, that this, that one, and all. Half an hour, 10 minutes, entertainment. That's all. No, come out. Rest of everything open. You should really think on all these things. Objects around you, make observation, rotating things. So what all I discussed, everything, try to construct. Take string, rod, pen. So what is this rod, sir? From where to bring rod? Take pencil, rod one, pencil, rod two, or take L-shaped rod, connect one rope at point A, string, thread, cotton thread, what we use to stitch the cloths. It's available. Just go to the any shop, no, they'll sir, where is the bob, from where I should bring? Take one small stone or eraser, finish or no. If you want to learn, unlimited. If you don't want to learn, then you give all reasons.